Hello, everyone, and welcome to NASA Unleashes Space Data Across the Senses at South by Southwest. We have a panel here today made up of some friends and colleagues that I'm very excited to be able to speak with and have a conversation with you. So today we'll be talking with Gary Foran, Alexander Stewart, Matt Russo, and myself, Kim Markand. The whole topic of today is that we have all of this fantastic data or information from objects in space that perhaps some people or most people are more familiar with experiencing as a two-dimensional image. You may have seen a famous Hubble space image, for example, on a computer screen or on a t-shirt or perhaps even on a backpack. But there are actually many more ways to experience this information using other senses such as touch, or even sound. So we can move through objects thanks to holograms and virtual reality or other forms of extended reality. And these data taken from telescopes in space or on the ground often are in light invisible to the human eye. So they must be translated or transformed into some way of experiencing it or knowing it. So in our discussion, we're going to sort of help you move from looking at cosmic images to listening to sounds representing things like black holes, or talking about how we can explore and walk inside the debris field of an exploded star. So we're going to start with some very brief introductions, and we're all going to talk a little bit about our background and then mention some of our recent work and perhaps a favorite example of going beyond a two-dimensional image. So Gary, would you like to start?
Thanks, Kim, and hello to everyone, and thanks for tuning in. My name is Gary Foran. I'm a graduate student in astrophysics at Swinburne University in Melbourne, Australia. As you can probably tell, I'm not your typical graduate student. I came to astrophysics from a previous career in X-ray physics and synchrotron radiation technology. I left that career as a result of a degenerative eye condition, which meant that I'm now actually functionally blind. So I have no useful vision, and made the decision to move into astrophysics. As you've already heard from Kim, astrophysics is often perceived as a very visual area of science, and we're all familiar with some of the fascinating and awe-inspiring images that we see of astronomical objects and phenomena. So you might think it unusual that someone with no vision would choose to go into that field. And so it's really great to be with you today to share with you my experience as a blind researcher in astrophysics and some of the applications of sonification, the transformation of digital data into sound, which enables me to do my research program and to follow a research path of discovery in astrophysics that is not obvious to anyone who doesn't have vision. I work in data sonification with colleagues in Melbourne, Australia, my PhD supervisor, Jeff Cookie, and our colleague at RMIT University in Melbourne, Jeff Hannam, who's the software and sound architect behind our projects called Star Sound and Vox Magellan, which I use to sonify data and to enable my research in high redshift galaxies. So I'll finish my introduction there, and I'll pass on to the next member of our panel.
Hi, thanks, Gary. I'm Alex Stewart. I'm a fourth year at Brown University studying computer science and visual arts. I've been working with Kim in the Chandra Observatory for 3 years now, and it's been a really cool experience. I mostly work on virtual reality experiences, and I think my favorite out of my time working with Kim in the Chandra Observatory has been a data sonification project in virtual reality that was centered around creating a way to interact with density data for the Cassiopeia A supernova. And it was a really enlightening experience getting to work with data and finding ways to interact with other senses other than sight, and kind of learn about the different technologies that we have available to us now, and kind of like working to create and improve um, to aid those who are visually impaired and just kind of create experiences for like inclusivity. And it's just been a cool experience for me. And I'm really glad to be able to like talk to you all today about what I've learned and what I've been able to contribute. And also hear from these other great people here on this panel too. So that concludes my introduction as well. I'll pass it off to Matt.
Great, thanks, Alex. So I'm Matt Russo. I'm a lecturer of physics at the University of Toronto. And for a while, I was an astrophysicist and a musician separately. And then in 2017, they discovered the TRAPPIST-1 solar system, which is the most musical solar system ever found. And since then, I began combining my two passions and finding a way to make the rhythms and harmonies of the cosmos audible. So sometimes that's converting the orbits of planets into music. That's the whole, music of the spheres idea that goes way back. And other times it involves sonifying images, so turning imagery data into something we can hear and process and experience in a different way. So I founded a project called System Sounds, which does just that. We do sonifications of any kind of data out in the universe or collected from the universe. And it's mainly for outreach and also for accessibility. Those are our focuses. So as a quick example of the kind of work we do, there's a really interesting picture called the Chandra Deep Field, which is the deepest X-ray image ever taken. And it shows about 5,000 black holes from supermassive black holes from very, very distant galaxies near the early universe. And the X-ray energies are represented by colors in this image. So from red through the rainbow up to purple. But the actual ranges of energies of the X-rays are on a much wider range. They're much wider range than our visual range allows. And so converting the colors into sound is one way to experience the different energy ranges of these black holes in the early universe. So I'll play a quick sample. So we're converting the low notes that are here shown as red. The colors red are converted into low notes, and colors up to blue, up to purple are heard as high notes. But in reality, it's an X-ray, so there aren't red and purple. It's a much wider range of X-rays. So that's just a sample of how you can take two-dimensional data and listen to it through time, through sound, as pitches, rhythms, volumes, timbres, and all the other parameters of audio. And I'll pass it off to Kim.
Thank you, Matt. I just love black holes. I mean, who doesn't love black holes? So that piece is just absolutely music to my ears. But I think out of all of us here, I'm probably the least musical / artistic / good at working with sound. So I am very much honored to be here with you all. My area of expertise, I think, is a little bit more in other kinds of data transformation. I work for NASA's Chandra Observatory, which is a telescope that goes about a third of the way to the moon. It's a sister telescope to the Hubble Space Telescope and gets to observe highly energetic regions of the universe, from things like exploding stars to areas around black holes to colliding galaxies. And I think that offers a unique opportunity to be experimental and creative with the ways that you can represent the data, because you are looking in a different kind of light that is very different than human eyes can perceive. So my job has been about figuring out different ways we can represent the information that makes sense for the science. And we started back in 2009 with creating like three-dimensional models with a scientist, Tracy Delaney, who was at MIT at the time. She created the first 3D model using the actual data of an exploded star called Cassiopeia A. And I think that was a bit of a turning point for me that just sort of set my career in a different direction. And fortunately, I have a work environment that allows me to play. And I use that word in like the grown-up word sort of for like being able to experiment and be creative. So we started working with 3D prints and then virtual reality, augmented reality. We moved into holograms. And then when the pandemic hit, and it was really hard to do anything with other people through virtual reality or 3D printing, sound was the answer. And I think it really helped me realize what a tool in any scientist's tool belt, or any person's tool belt, I suppose, to be able to have sound to represent information in a new way. So all in all, my job essentially is about telling stories with data. My PhD is actually in a strange combination of astronomy, computer science, sociology, just toss in a little statistics, whatever you want. But I'm very thankful that I get to work with people like everyone here in order to be creative with the ways that we unleash this NASA data. So with that in mind, let's think about our first question. So what are the various types of NASA data that we are working with here? Perhaps one of us can get a little bit deeper into that. So what are we discussing for these visualizations, for these representations more specifically? You know, these are not giant space selfies. So what is it we're working with? And who wants to start with that? Gary, perhaps you?
Sure. My the area of research that I'm currently working in is what we call high redshift galaxies. They're galaxies, very distant galaxies, galaxies from the very early universe. So the light that we detect from those very distant galaxies is extremely faint. It requires the world's biggest telescopes to see, and requires long observation time. So we're really working at the bleeding edge of what's observable in the distant universe. In spite of those challenges, the information is very rich. I come from a background in spectroscopy. That's where we look at the energy spread of light, how that light is distributed in energy and at different wavelengths. And by using the advanced instruments at the world's best telescopes, I study the kinematics of galaxies. That's how they move. I look at their sizes, their shapes. We interpret their masses and other properties, and look at statistical methods whereby we can take a small sample of galaxies and say things about lots of galaxies. The challenge for me is that spectroscopy it looks like a line on a graph. It goes up and down, and its position on the graph and the strength of that line is what's usually interpreted by someone visually to untangle the physical information from these galaxies that are far, far away. I use sound to interrogate those spectra, to see what the changes in amplitude, the strength of the light at different wavelengths. That's actually a simple application of sound that I use. A more sophisticated and one that is really exciting for us is one where we now take the 2D images and we pixelate that image at a resolution scale that we need, that is accessible. And I can actually interrogate the way the gas in that galaxy is moving either towards me or away from me using sound. And we've got some very beautiful sonification techniques that use effectively the Doppler shift effect, the same effect that you hear when an ambulance goes past you and the sound goes from a high pitch to a lower pitch. We use the same thing as the Doppler effect in gas in distant galaxies to look at how that gas is moving and how the movement of that gas correlates with other properties that we can observe. So that's the sort of information at a very, a leading edge research level that I'm using sound for to help me in my work.
And I think a key point of that is that, for many people using astronomical data, there are many different kinds of information that you can harness, like Gary mentioned. So it's not just optical light, you can gather infrared light, you can gather X-ray light, you can gather many different kinds of light. And each different kind of information adds a piece of the puzzle. But again, with all of those different kinds of information, they all have to go through a process of transformation, because it's not just a point and click and shoot and you've finished, right? You have to be able to translate that information by following the science story into a format that can then be used or exported in some other way. So I think really interesting is most of the work that I get to do, and I think Matt and Alex as well, has definitely been in combining different kinds of light. So it might be Chandra X-ray light, as we mentioned, but we're also going to include Hubble optical light, which can often provide a lot of really good context. You might include Spitzer infrared data or data from some other telescope, even a ground-based observatory as well. But it's really the idea that you can sort of pick the best tool in your toolbox in order to be able to answer some question or provide some output in a very creative way. So I don't know, or Al, if either of you want to add to that sort of general topic before we move on.
Yeah, there's that one thing about multi-wavelength imagery. So if you take images from different telescopes and combine them, if you just layer them on top of each other, it's often pretty hard to identify the different features in the different images. But this is one advantage of sound. If we convert each layer into a different sound, our ears have the ability to process separate streams. So the same way you would process different instruments in a song, they're all happening at once, but your ear can pick out and identify certain ones. So we can use that machinery of your auditory system to listen and process multiple types of light at the same time.
So I guess we might switch at this point that, again, we've kind of covered a little bit that much of this data is being captured non-visually or in lights or other kinds of information that humans can't naturally detect. So I guess I would ask everyone, does that give you more allowance to be creative with the kinds of outputs for the data? So not just the 2D imagery, obviously we've talked about sonification. Perhaps we could zero in a little bit more on virtual reality, 3D modeling, and or some of the haptic technology as well. So Alex, I'd love to toss that over to you. Maybe you could describe a little bit more some of the projects you've worked on and that idea of being able to be creative with how you approach the information.
Mm-hmm. Yeah, I think one thing that definitely comes to mind, and it was something that Matt had started to touch on, is kind of the multimodal aspect of how we can interact with this different data that we're receiving. For example, with my project, the goal was to create a sonification of this density data that was accessible, not necessarily just from sight. Sonification being like the visualization of data through sound. And one of the cool things of trying to find different ways to represent this data was you don't necessarily only have to use sound. Like Kim mentioned, with the use of VR headsets, we have access to controller haptics, which allowed me to kind of try to create this space where you can navigate not only through what you're hearing from 3D audio in the headsets, but also through haptic vibrations, giving you kind of like a sense of awareness of when you're getting close to something that we consider to be important or something we want you to kind of like zero in on as you try to experience the data. You can kind of activate all of these different senses around you to kind of guide and lead you to what we want you to kind of get out of the experience, which definitely opens up a lot of windows for creativity and how we want to represent the data in the best way possible, which I think is a really challenging thing. And I think what is really beautiful about what Matt created, him talking about the different timbres and the different ways that we can experience and identify sounds. I think for me, it was a really difficult process to try to kind of overcome and figure out what the best way to do that is. But when you get those beautiful sounds and kind of can distinguish different aspects of the data in unique ways, I think it's like a really beautiful process.
Yeah, I like what you're adding there about the sort of the marriage of the science and the art. So sorry, I think I cut you off, Matt, but please go ahead, talk more.
Yeah, I was going to say, I love, Alex, what you just touched on, which was that there's something critical that you're trying to communicate. You're trying to point the users to notice the really fascinating thing about the data. and you have many tools to do that. And so when we work in sonification, we have all the musical tools, and we're trying to make that thing that's interesting and fascinating about the data obvious and completely accessible to someone, so that it's like it's bare and exposed. And having all these different tools, that can help, because different features are highlighted better with different methods.
And I think it speaks to the broad appeal of a multisensory approach to data analysis and to image interpretation, because as Matt and Alex have mentioned, by applying sonification and haptic and other techniques, it forces you to realize that the 2D image on the screen is just that. And what is on the screen is really a poor representation of the real physical object, which is actually a 3D body that's not standing still, that is multi-phase with multi-properties. And it really opens up the mind to the true nature of the astrophysical object, rather than being limited to a 2D color image on a screen.
And I guess I'd love to talk a little bit more about the potential benefits as well as some of the pitfalls when you do have to work in this multimodal way. I know for the project that Alex worked on, trying to attach sound data and haptic information to a virtual reality, an object in virtual reality, was technically very challenging. We hadn't seen that done before. We weren't 100% sure what steps to take. So it can be challenging to do, but there are many benefits of doing it. And of course, there's always going to be pitfalls along the way. So perhaps, Gary, you could start and talk a little bit about some of the benefits, or what you see as some of the things that you have to pay attention to when you are working through this multimodal experience.
Yeah, I think as I think we've just a segue from the last point is that there's definitely advantages in a multisensory approach, and it makes perfect sense, of course, as Alex has intimated. The gaming community has known this for a long time, that multisensory and including VR and haptic type interfaces is the best way to interact with an environment or a data situation. And I guess we've been a bit slow on the uptake in that sense. So redundancy of sensory perception is good, because it means that we interpret the data as a whole. It's more efficiently transferred and it's easier to remember when we apply a multisensory approach to it. So as a general concept, there's no question that a broader attitude towards the interpretation of images, especially, it has a lot of benefits. The challenges and the pitfalls can be that there is undoubtedly, and there's a good reason why visual perception is our dominant sense, because it's very good, and it's very good for helping us move around in the world and to the way we interact socially and physically with the world. A vision specialist told me once that approximately 80% of our sensory input comes through our eyes. There's a good reason for that. It's an excellent sense for what we need to do on a normal basis. But there are things that our other senses do, both synergistically together with our vision and independently of our vision, that actually have advantages over visual perception. Speaking specifically to audition or to sound, there are things that we do with our ears, with our audio perception, that actually surpass what our eyes can do. And that's in fact why we have ears. And they include things like our ears are very good at 3D spatial perception. Our eyes just look at what they look at. Our ears can in fact resolve in 3D around us where sounds are coming from. So in a VR type context, for example, that can be enormously powerful sensory modality. Our ears are very good at what we call temporal resolution. We can hear the difference between two sounds in time much better than we can with our eyes. Our ears are also very good. Our audio perception is also very good at response time. We can respond far quicker to an audio stimulus than we can to a visual stimulus. And in fact, you see that sort of thing already in applications, for example, in warning systems in aircraft safety and in the military. Audio warnings are used because it's been proven that we can respond faster to an audio warning than a visual warning. And of course, our ears are also very good, and most people will be familiar with the idea of what we call the cocktail party effect, where our ears are extremely adept at picking up out of a noisy background a sound of interest, whether that be a conversation on the other side of a room, or whether that be, a blip in a data stream. Our ears can be very, very adept at picking up low signal to noise data. So if we concentrate on the areas where audition has its strengths, and combine that with visual perception and other modes of perception, that's where we stand to get the most benefit out of the combination or a multisensory approach.
And I guess I would segue from that and just toss out another question to Matt or Alex, like, why do we enjoy doing this? At least I enjoy doing this type of non-traditional representation. I would love to hear if you do too, and if so, what you think it brings to you or to the end user.
I can speak on this a little bit. One, I think it's just rewarding. Getting to try to tackle these problems and also have what we spoke about before, this artistic freedom to try to represent this different data. It's just a really rewarding feeling when you can see and actually experience what you've created and see others experience what you've created. It's a rewarding feeling. And also it's pushing tech in the right way to creating what the whole aim is of having like this inclusive space where everybody can experience what is being created. It's not excluding certain demographics from the story, which is one of the main reasons I really enjoy working for Kim and working at the Chandra Observatory as like a research assistant. It's been really rewarding to know that I'm aiding in moving along tech in that direction. That's one of the main reasons I partake in this research.
I love that answer. Matt, do you have any follow-up? That was great.
Yeah. For me, it's extremely enjoyable because it really feels like exploration and discovery. And I feel the same way when I'm composing music or sonifying a data set. I don't know how it's going to work. I know there's going to be all kinds of challenges I get to solve along the way. And then at the end, you can kind of look back and be surprised at what happened. And then, as Alex said, the best part is sharing it with people, and it becomes a communal experience. And it's just an endless source of enjoyment, fun, wonder, challenges. So I'm going to keep doing it.
Yeah. I agree. For me, it's just like every time I'm in the sandbox of data and I get to play with moving it in one new direction, every step has been so rewarding, whether it was a 3D model, a virtual reality, a haptic, the vibrational information or the sound, like every piece of that journey of that multimodal experience has been such a joy for me as a person, but also from being able to, as Alex mentioned, I think, be a part of moving that data in the right direction, moving that experience in the right direction, utilizing technology for what I think is fantastic, and just being able to contribute to the way people perceive and understand something that we should all have access to. So yeah, that is fantastic. I guess I would move to the next question, that how might emerging tech inform even new directions in future outputs, right? If you had told me 20 years ago when I first started working for Chandra, right before it launched, that I would be walking around inside a dead star and listening to a field of 5,000 black holes and feeling my way through other types of data, I don't think that I would have believed you. So where might emerging tech like keep pushing us in this type of direction? And who wants to take that first? Alex, do you want to try that one?
Sure. I think The immediate thing that comes to mind is how these technologies we're using are constantly improving. For example, I always think of like the PS5, and they have this new controller with this state-of-the-art haptic system that adapts to how hard you can press the triggers. And thinking about the use of that outside the context of gaming, it's really powerful. It adds another level of depth that we can add to like multimodal experiences. So as tech continues to advance, our toolbox only gets bigger. And I think that's like a really cool thing to think about, like VR, XR, AR. It's the future, really. It's just going to keep getting better, and it only helps everybody involved. So I'm really excited for tech to keep growing and getting more, I guess, complicated in a way, but better.
Matt or Gary, do either of you want to talk about what you think might be happening in the future?
I think from a research perspective, which is where I'm coming from in the application of these techniques, it is exciting to remember that in research, often the new discovery is the unexpected one, and at the same time, conventional methods of data analysis, almost by definition, lead to conventional interpretation and often conventional results. Not necessarily, but they can do. And so alternative methods of interacting with data, disrupting the conventional way of analyzing things and looking at things, makes you open to the possibility of the unexpected and the new discovery. And I guess that's the exciting thing I can see, not only for visually impaired researchers, but also for the mainstream research community, that by opening yourself up to multiple sensory input, you're making yourself available to see something that you wouldn't have seen otherwise. And I think that's an exciting way forward for this type of approach.
And the aspect I notice and enjoy most isn't so much a new technology, it's just the more widespread access of data and programming. So it's way easier now than it was in the past to get your hands on astronomical data, and much more of it, of course. And more and more people have basic programming skills these days, and so it becomes more accessible to everyone to get in and get their hands dirty and start exploring the data in whichever way they want.
Yeah, I feel like I definitely don't have a crystal ball, so I'm not sure if I can really predict where things will go from here, but I love where we are now. And I love the fact that like each new thing we've been able to play with, each new technology we've been able to invest some time with, each way of representing we've been able to sort of experiment with, has led to some new question to ask or some new thing to try. And it's just a chain reaction that just keeps unfolding like a beautiful piece of origami that's, able to be unfolded. And I think for me, this whole experience so far has been like every time we do something new, we get rewarded. So why would we stop, right? So it's like this idea that when we created some of these 3D prints and they ended up being so eminently useful. We worked with students who are blind or visually impaired to improve those models, and they made those models better for everyone. And the same thing with the data sonification, when we worked with a community to be able to create something or improve something or work with them to provide something new for them, it then enabled other people to be able to enjoy in that process. And the data sonifications have just done so well and done so beautifully. I think is an example of when you take the time to explore something new, and when you take the time to work with a new community, that you also just help everyone benefit a bit. So it's just been really fun. And I guess in that light of helping other people have fun, would any of you have some specific advice for how people can get involved and start working with these non-traditional methods themselves, not necessarily just in astronomy, which is obviously our flavor here, but perhaps the application of that type of non-traditional method for visualization in other areas as well. Does anyone want to take that?
Sure, I can start on the sonification side of things. The barriers to entry are shrinking. It's very easy to get started with sonification. There's a few online options. There's something called two-tone, where if you upload any data you want and you get some controls to turn it into music. And there's other things. One that's called pixel synth, which is a way to convert image data into sound, all web-based. You just pick an image and you can start having fun. And then, to really get a little bit more serious, you just need very basic programming skills. So you can do it in simple Python, and it may be easier than you think to take any source of data, maybe an image, or maybe it was never an image to begin with, or at any stage, and convert that into audio signals. And so, yeah, it's easy to get started.
Gary?
Yeah, I think certainly members of this group will be aware, and to anyone listening, there's a real groundswell of interest in this type of thing around the world, and we meet regularly, once a month, in fact, in what's called the Sonification World Chat Group, and that group is not limited to sonification, but there are also Slack channels associated with that handle look at haptics and 3D technology and other multimodal approaches. Within the activities of the Sonification World Chat, there is currently underway a survey of all the existing tools, and there are a number of them out there that are that are pre-packaged and ready to use for in bringing in data, and quite accessible in terms of being able to turn things into sound very quickly and without a great deal of drama. As I said, Star Sound, which we use, is available online and to be downloaded. There are others, and if you look around for the Sonification World Chat, you'll certainly find in very soon online there'll be links to a lot of the tools that are currently being in use and being developed around the world for this type of approach.
And Alex, any suggestions related specifically to virtual reality or haptic or any of the other cool projects you've gotten to work on that you think might be useful?
Yeah, I think one thing that is definitely troubling about VR is there can be like an economic barrier, especially when it comes to these really expensive headsets. But one thing I've been realizing is all you really need is a smartphone. You can access VR applications through this like new emerging system of web VR. So there are these different frameworks, like as Matt mentioned, as you begin to kind of explore coding and get into that sphere of technology, really the power is at your fingertips. You can create these web applications that mimic VR experiences on your phone. You can turn your phone and experience kind of like this 3D space through your lens of the screen of your phone, right? And I think that's a really powerful step in opening up the accessibility and a really good starting point for experiencing VR, which I would definitely suggest. Kind of Matt mentioned getting into coding and like dipping your foot in, because personally for me, what got me on this track and really pushed me to learn to code was kind of like dipping my foot in and finding communities that helped me and propelled me to kind of continue exploring what I was learning. And I found that to be really helpful. And I would tell anyone to kind of pursue the same.
100%. And I guess I would just add that it's, I think, particularly helpful that NASA data is for the most part public domain. So there's always a bit of a treasure chest for you to be able to work with that type of data. And it is really interesting and exciting to see how other fields of study will be adding to this conversation, already have added to this conversation, whether it's something in molecular biology or some other field of study. So I just want to say thank you, all of you here, so much for joining in this conversation. And thank you for all that have been listening, for joining us at our South by Southwest panel as we tried to talk about how NASA data can be unleashed across the senses.